I haven't had a cigarette in like 4 weeks. So
good job, man. How's it feel now? Is it like you still just like, damn it?
yeah,
Really?
oh yeah, yeah. But it's a like I was just thinking about how to describe it, and it's about getting into the habit of being out of the habit. That's what it is for me. I have all of these things that I do in which habitually I'm reaching for the smokes. And so I sit down to do that thing.
Traps everywhere.
Mouse traps. Jesus Christ.
Retrain your habits real quick.
Well, the habit is just, it occurs in my brain.
Yeah.
And then I'm like, but I don't have any. So I reach for the vape. So I've been wondering if this is like extending the problem.
Oh yeah, I've wondered that too.
You know?
Yeah.
It's like, would the problem, this, you know, that inclination be gone if I didn't have the vape, because I still reach for something and I still take a pull on something. But whatever, you know, it's working. It isn't that bad. It's just annoying sometimes.
Yeah. When I switched to the vape, I started just like, you know, blazing this thing nonstop. And so then I was like, okay, I need to chill out. And then I moved to like the lower nicotine level.
Yeah.
Which kind of helped me like get, you know, it's just, you just don't crave it as hard. Like, I guess you're getting less nicotine.
Yeah.
I don't know. So I really had to try to make myself like not pick it up constantly. But
yeah, I don't know. It doesn't feel like a craving for nicotine. It's just like there are these habits that are built in. But maybe it is. I don't know. I can't really identify what it is. But I'll be doing whatever it is, like reading or, you know, whatever, and like where I would normally light up a smoke, and then that's when it occurs to me, and then that reminds me that I don't have a smoke.
Yeah.
You know, and
that's what makes you even need a smoke.
Yeah, and then
stressful.
And I'm like, God damn it! And then I pick up the vape and I take a couple of hits, and then I forget and I put it down and I do keep doing whatever it was I was doing. So I was just wondering if like, because for most of the time I'm not aware. You know what I mean? Mm-hmm. Like, and the longer you can go where you're not aware that you quit smoking, the better.
Yeah.
That's how I look at it. It's the same way I deal with the back pain, right? I have an injured back, and there's this like response thing where it's like the longer you can go without being aware that your back hurts, the better you are.
Yeah.
So the longer you can go without being aware and being reminded like, oh yeah, I quit cigarettes, damn it. You know, so I was joking with people when I first did this that like every morning I woke up and I was like, oh yeah, fuck. You know, make the coffee and then you want the smoke and you're like, oh yeah, I quit that. That sucks.
Yeah.
But anyway, yeah, it's not too bad. It's really not too bad. But yeah, I just wanted to because people have asked like, what is that hissing noise? And that's me.
It's turning into a snake. Just don't talk with it in there because you're
right. Yeah. All right. You got stories? I've got a story.
I do. What is your story on the moon?
My story is on the moon.
Start there.
Okay.
And then we'll move into deeper space.
So this is not new. This is from June 24th. Some people probably heard of this, but I did get this from NASA.gov, so it's totally trustworthy. NASA's Lunar Reconnaissance Orbiter spots rocket impact site on the moon. So astronomers discovered a rocket body headed towards a lunar collision late last year. So they detected it at the end of 2021. And the impact occurred on March 4th, with NASA's Lunar Reconnaissance Orbiter later spotting the resulting crater. And surprisingly, the crater is actually two craters. There's an eastern one and a western one. The eastern one is superimposed upon the western crater. They're both about the same size. One's 18 meters or 19.5 yards, and the other one is 16 meters or 17.5 yards. This double crater was unexpected and may indicate that the rocket body had large masses at each end. Typically, a spent rocket has mass concentrated at the motor end. The rest of the rocket stage mainly consists of an empty fuel tank. Since the origin of the rocket body remains uncertain, the double nature of the crater may indicate its identity. No other rocket body impacts on the moon created double craters. The 4 Apollo SIVB craters were somewhat irregular in outline. These were from Apollos 13, 14, 15, and 17. And they were substantially larger, greater than 35 meters, or around 38 yards. The maximum width, 29 meters, or 31.7 yards, of the double crater of the Mystery rocket was near that of the SIVBs. So that's the combined width of the two craters. LRO, or Lunar Reconnaissance Orbiter, is managed by NASA's Goddard Space Flight Center in Greenbelt in Maryland for the Science Mission Directorate at NASA headquarters in Washington. Okay, this is just a thing for the LRO. So anyway, I guess that's the end of the story. They got a couple of pictures here of the craters. It does look like a double impact.
I thought people were saying it was like a Chinese rocket or something.
Well, I mean, the reason why it's unknown is because just no one has claimed credit for the rocket, and then so that makes it a mystery. But no one is thinking that it's something weirder than it's just some other nation's rocket that we don't know about. I mean, I guess some people are. It was aliens. I don't know. But the point is that somebody crashed a rocket into the moon or lost control of a rocket or something, but no one has claimed credit. None of the Western nations, and so maybe it was a Chinese thing. I'm not sure. But the other mystery about it is why it made two impacts.
Yeah.
Did it break up before it hit and two distinct pieces impacted?
And they must have been close to the same mass.
Right.
To make the same size crater.
Right. And that's why it's interesting. Is like normally you have a mostly empty tank and then a big, heavy, massive engine at one end.
Yeah.
So if the tank came off and then the engine hits, it would make a big crater and the tank would make a little bitty thing. But this one has two almost the same size. So that makes it interesting. Did it have some kind of payload that was massive?
That's strange.
Yeah. And maybe there's updates. I don't know. I haven't looked. It's possible that there's updates, but I haven't seen anything yet.
Well, the future audience will probably know the answers.
That's right. Yes.
Right now, we don't know what's going on. My phone is about to die.
Uh-oh.
Let's see here. No, don't want that. All right, so this is from Science News, ScienceDaily.com, sorry. Astronomers detect a radio heartbeat billions of light years from Earth. So this is about fast radio bursts. Astronomers at MIT and elsewhere have detected a strange and persistent radio signal from a far-off galaxy that appears to be flashing with surprising regularity. The signal is classified as a fast radio burst, or FRB, and an intensely strong burst of radio waves of unknown astrophysical origin that typically lasts for a few milliseconds at most. However, this new signal persists for up to 3 seconds, about 1,000 times longer than the average FRB. Within this window, the team detected bursts of radio waves that repeat every 0.2 seconds in a clear periodic pattern, similar to a beating heart. The researchers have labeled the signal FRB, really long number, and it is currently the longest lasting FRB, as they all are.
Yeah.
It is the currently longest lasting FRB with the clearest periodic pattern detected to date. The source of the signal lies in a distant galaxy several billion light years from Earth. Exactly what that source might be remains a mystery, though astronomers suspect the signal could emanate from either a radio pulsar or a magnetar, both of which are types of neutron stars, extremely dense, rapidly spinning, collapsed cores of giant stars. There are not many things
Yeah, okay, I have questions, but you keep going. Sorry.
There are not many things in the universe that emit strictly periodic signals, says Danielle Micheli, a postdoc in MIT's Kavli Institute for Astrophysics and Space Research. Examples that we know of in our galaxy are radio pulsars and magnetars, which rotate and produce a beamed emission similar to a lighthouse. And we think this new signal could be a magnetar or pulsar on steroids. The team hopes to detect more periodic signals from this source, which could then be used as an astrophysical clock. For instance, the frequency of the bursts and how they change as the source moves away from Earth could be used to measure the rate at which the universe is expanding. Now, that's a cool idea. because it's so periodic. But how would they know if it was just slowing down? The discovery is reported today in the journal Nature, and it's authored by members of the CHIME/FRB collaboration, including MIT co-authors, blah, 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 a bunch of other people. Since the first FRB was discovered in 2007, hundreds of similar radio flashes have been detected across the universe, most recently by the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, an interferometric radio telescope consisting of 4 large parabolic reflectors that is located at the Dominion Radio Astrophysical Observatory in British Columbia, Canada. CHIME continuously observes the sky as the Earth rotates and is designed to pick up radio waves emitted by hydrogen in the very earliest stages of the universe. The telescope also happens to be sensitive to fast radio bursts, and since it began observing the sky in 2018, CHIME has detected hundreds of FRBs emanating from different parts of the sky. The vast majority of them, to date, are one-offs, ultra-bright bursts of radio waves that last for a few milliseconds before blinking off. Recently, researchers discovered the first periodic FRB that appeared to emit a regular pattern of radio waves. This signal consisted of a 4-day window of random bursts that then repeated every 16 days. Yeah, you remember this one? I think this is the one that I did a bunch of stories on, this 16-day period one. Yeah. This 16-day cycle indicated a periodic pattern of activity, though the signal of the actual radio burst was random rather than periodic. So like 16 days, it would come on and do this random flashing, and then it would shut off, and then 16 days later, it would come back on and be a completely different set of flashes.
Yeah.
Remember that?
Yes.
These things are so weird. And this is also reminding me of the actual visible light flashes that we've seen in the sky.
Oh, yeah. Yep.
Sometimes there's just one flash. Sometimes there's like a couple, and then there's been a few times when we've sat there and just watched the things flash over and over, but not like a regular period.
That's right. Yeah.
So maybe there's visible.
But every 16 days is non-random, but then the flashes are totally random.
Yeah.
Yeah. That's weird.
Yeah. So this new one says, let's see. Well, I'll just keep going. On December 21st, 2019, CHIME picked up a signal of a potential FRB, which immediately drew the attention of Michili. I don't know. His last name, it looks like Michili, who was scanning the incoming data. It was unusual, he recalls. Not only was it very long, lasting about 3 seconds, but there were periodic peaks that were remarkably precise, emanating every fraction of a second, boom, 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 like a heartbeat. This is the first time the signal itself is periodic. In analyzing the pattern of this fast radio burst, Michili and his colleagues found similarities with emissions from radio pulsars and magnetars in our galaxy. Radio pulsars are neutron stars that emit beams of radio waves appearing to pulse as the star rotates, while a similar emission is produced by magnetars due to their extreme magnetic fields. The main difference between the new signal and radio emissions from our own galactic pulsars and magnetars is that the FRB appears to be more than 1 million times brighter.
That's what I was going to say. We have these objects in our galaxy, but this thing is like a couple of billion light years away. Mm-hmm. And so I'm just like, no, that whatever is happening is way beyond the pulsars that we have next to us.
And so I just wonder if it's like, if there's like this weird Doppler effect that makes it looks to us as being this very rapid thing that takes place in milliseconds, but maybe what's actually happening in that place in the universe is like a longer, slower process, like if you were there.
Yeah.
You see what I'm saying?
Yes.
I don't know.
Or some lensing object is passing between us and it.
Yeah.
You know? So if there's like a singularity that moves between us and it somewhere out there, and for a brief moment, like it gets magnified by.
Oh, I see what you're saying. Yeah. And that, yeah. Why would it be random most of the time?
There's a bunch of them.
But then not random every 16 days, right? It's so weird. This is so strange to me.
It's shotgun blasts.
So Michili says that the luminous flashes may originate from a distant radio pulsar or magnetar that is normally less bright as it rotates, and for some unknown reason ejected a train of brilliant bursts in a rare 3-second window that CHIME was luckily positioned to catch. Chime has now detected many FRBs with different properties, Machili says. We've seen some that